Hello, welcome to the NCEA Level 3 Complex Numbers tutorial 2021s, and let's get right into it. So, question 1, given that W equals D plus 5i and Z equals 3, take away 4i, find the value of D if WZ equals 38, take away 9i. So WZ is equal to D plus 5i times, so that's D, this W, and 3 take away 4i. To expand out 3D, 3D, take away 12DI plus 15i, take away 20i squared is equal to 8, take away 9i, but 20i squared is -1, so this can be taken away and turned into a plus. So we can combine, so 3D take away plus 20 take away plus 15 take away 12D I is equal to 38 take away 9i. And what we can do from here is we can pair the real parts together, or pair the imaginary parts together, but in this case pairing the real parts will probably be easier. So 3D plus 20 is equal to this 38. 3D is equal to 18, therefore D is equal to 6. And there we go. How do I zoom out? Okay, yep. So if Z equals 2 plus 3, I showed 26 over Z on the diagram below. They haven't really given us much space to work with. So 26 over Z is 2 plus 3i. We want to get rid of this denominator, so we multiply it by the conjugate. Multiplied times multiply, take away 3i. So 52 take away 78i all over. So that's 4, and then the 3i times 2 and -3i times 2 cancels out, so 4. So -4 take away 9i squared, which is equal to 52 take away 78 over 13, which is equal to 4 take away 6i. And we can so this 4 is the real part and -6 side is the imaginary part. 4 so 4 is here, and so 6i is in the imaginary part is here, so is this way. So 4 plus 6i is here, so so here is 26 over Z, and there we go. If x cubed, if the binomial if x equals x cubed plus 3x squared plus ax plus b has the same remainder when divided by x take away 2 as it does when divided by x plus 1, the binomial if x also has x plus 2 as a factor. Find the values a and b. So if this part, if x is divided by x take away 2 and it has the same remainder as x plus 1, that will mean if brackets 2 is equal to brackets -1, since we get, yes, so x take away 2, that means x is equal to 2. So if 2 equals and x plus 1 means -1, so f2 equals f -1. So let's plug in, and f2 is equal to 2q plus 3 brackets 2 squared plus 2 brackets a plus b. So 8 plus 12 plus 2a plus b. So 20 plus how do we do it? Yeah. 20 plus 2a plus b. If -1 is equal to -1 all cubed plus brackets -1 all squared plus a brackets -1 plus b. -1 plus 3 minus a plus b. So 2 minus a plus b. The b's cancel out. So 3a is equal to -18. A is equal to -6. So know that a is equal to -6. And so x plus 2 is a factor, so if brackets -2 is equal to 0. So what's the polynomial again? So -2, right? Yeah, -2 cubed plus 3 brackets -2 all squared plus brackets plus a brackets -3 plus b is equal to 0. So -8, 4 is 12, take away 3a, b is equal to 0. 20 take away 3a plus b equals 0. But then we know that a is equal to -6, so we can plug into here. So 20 take away 3 brackets -6 plus b equals 0. 20 plus 18 plus b equals 0. Therefore, b is equal to -38. Let's see. If z equals 1 plus 3i, then argument of z take away 1 over z take away 2i is equal to pi over 4. So that means 1 plus I take away 1 all over 1 plus 3i take away 2i. So 3i all over 1 plus I, and we want to get rid of the conjugate again, so multiplies by, we want to get rid of the denominator, so multiply by the conjugate. So 3i take away plus 3 all over 1 plus 1 take away I squared, which is 2, and so we can see here, so which is equal to 3 over 2i plus 3 over 2. So z take away 1 all over z take away 2i is equal to this. So what this argument is saying is, so in an Argand diagram like this, 3 over 2i plus 3 over 2, the point z take away 1 over z take away 2i will be here, and the angle between here to here, this will be pi over 4. And what we know about pi over 4 is pi over 4 is 45 degrees. And so whenever, so basically, so here, 45 degrees but we always know the angle between the real part and this, and the real part will create a right angle here. So this is also will also be 45 degrees. So for an argument to be pi over 4, it must be a isosceles triangle. We must create an isosceles triangle. So here to here. So the imaginary part and the real part must be the same, which it is 3 over 2 and 3 over 2. Therefore, so let's just write it here. Because imaginary and real are equal, because argument of z take away 1 over z take away 2I is pi over 4. I believe that's just all you need to write, since if the real part is imaginary part is equal, it will create an isosceles triangle with the modulus, and so the isosceles triangle will have a right isosceles right triangle will always have the argument pi over 4. Okay, let's go to the next page. This is the excellence question. So given that the real part of z take away 2I is 0 and z unequals 4, prove that the locus of point described by z is given by the Cartesian equation x take away 2 squared or plus y take away 1 squared equals to 5. Okay, so z take away 2, we want, let's just so z is an imaginary number, and yeah, we just assume that z is an imaginary number, x plus yi. So so basically z take away 2I over z take away 4, that will mean x plus yi take away 2I all over x take away 4 plus yi. So we want to multiply this, so we want to multiply the conjugate of this to have a real denominator. So the conjugate will be x take away 4. So this is the real part and this is the imaginary part, and we want to flip the sign in between there. So x take away 4 minus yi will be the conjugate. So let's just get rid of this equal sign. X times x take away 4 take away yi all over x take away 4 take away yi. So we can multiply this out. Let's get rid of this, we don't need this. So what is the easiest way? Let's just multiply the real parts with real parts. So this is the real part and this is the real part. So actually no, let me just rewrite it here. X plus I brackets y take away 2 over x take away 4 plus y I times x take away 4 take away y I all over x take away 4 take away y I. So let's multiply the So here and here, x squared take away 4x. Here and here, take away xyi. Here and here. Plus x take away 4 brackets y take away 2i, and here, so negative, so take away y brackets y take away 2i squared all over. We can just say this. We can just multiply the real parts and the since because of the conjugate, the imaginary parts times real parts cancels out. So it'll be x take away 4 all squared. So minus y times yi will be minus y squared I squared. Let's just rewrite it nicely. So x squared take away 4x take away xyi plus x take away 4 y take away 2i plus y squared plus, oh no, not y squared, plus y brackets y take away 2 all over the x minus 4 all squared plus y squared. So, to be honest, in this, the question was saying the real part is 0. So what that means, we gather all the real parts and equate it to 0. So actually the denominator here doesn't matter too much, since it'll equate to 0, and we can just ignore the imaginary parts. So we can just ignore these two things, yeah. So x squared take away 4x plus y brackets y take away 2 is equal to 0. Yeah, this is looking promising. So x squared take away 4x plus y squared take away 2y is equal to 0. So to get to form a perfect square, we need to get a constant and get it's hard to explain. So we get the polynomial that's in between the constant and the largest polynomial. So in this case, x squared. So we want to get half of x squared, which is 1. So 4x to the power of 1. And we want to have this. So we want to say x take away 2 all squared. But this x take away 2 all squared is, but to form x take away 2 all squared, we had to add 4 on this side, because x squared take away 4x, x take away 2 all squared is equal to x squared take away 4x plus 4. This. So we will add 4 on. Oh no, we want to add 4 on both sides. So let's just add on this side. And half of negative 2 is 1. So y take away 1 all squared. And we added 1 on this side because y take away 1 squared is equal to y squared take away 2y plus 1. So let's also add 1 on this side. So therefore the Cartesian equation of this polynomial, of the complex number, is this: x take away all squared, x take away 2 all squared plus y take away 1 all squared equals 5, which is exactly what we wanted to prove. Let's keep going here. U equals 2I and W equals 2 says 2 pi over 3. So if 2I, that means in an Argand diagram it will be here, because yeah, this is just the imaginary line. Yeah, so this is the imaginary line and this is the real part. So it will always stay an imaginary number. This is it's just one imaginary number and no real number, so it'll always stay on this line. So, and the angle it creates from the origin is a right angle, and a right angle is pi over 2. So this can be rewritten as, so U can be rewritten as 2 cis pi over 2, and U over 2 cis 2 pi over 3 pi. I'm sorry. So and then it's just 2 over 2 cis brackets pi over 2 take away 2 pi over 3, which is equal to, so this just is 1, so cis what is that? Is that 3 take away 4 negative pi over 6, I believe. Actually, I didn't. No. I need to give the exact value. So cis actually means cosine cis theta is equal to cosine theta plus I sine theta. So cosine negative pi. So cis negative pi over 6 is cosine negative pi over 6 plus I sine negative pi over 6, which is equal to, where's my calculator? Cosine negative pi over 6 plus I sine negative pi over 6, which is equal to root 3 over 2 take away half I. Solve the equation x squared take away 12x plus 20q squared, expressing this equations in their simplest form. So we want to form a perfect square with x squared take away 12qx. So we want to form x minus 6q all squared. So to form this, we need to add 36q squared to both sides. So x minus plus 20q squared is equal to 36q squared. So x why is my pen not working? Excuse me. What? Excuse me. What? This? Do I need to rub stuff out? No, my rub is also not working. Right. think I will just continue with here. And can I make this? Can I, why is it? Wait, let me just stop this real quick. Sorry for the technical trouble. So we are back. So, so x minus 6q squared plus 20q squared equals 36q squared. X minus 6q squared is equal to 16q squared. Then we can take the square root of both sides. So x minus 6q. Okay, so, and when we take the square root, we will need to consider the plus and minus of it. So plus minus 4q. So x plus equals 6 plus minus 4. 6q plus minus 4q. So x is equal to 2q and 10q. Okay, a plus bi, b take away ai. Here a and b are real constants, so prove that this is imaginary. So we want to, so always, if there is a imaginary in the denominator, multiply it by the conjugate. So a plus bi over, take away ai, multiply that by b plus ai over b plus ai. So ab plus a squared I plus plus b squared I take away plus abi squared all over b squared take away a squared I squared, and I squared just turns into -1, so ab plus a squared I plus b squared I take away ab all over b squared plus a squared. Then these two cancels each other out, so a squared plus b squared all I all over squared plus b squared. This, and then since so a and b are real constants, and a squared plus b squared will just be a real number, but the denominator doesn't really matter since the numerator is a purely imaginary number. This is a purely imaginary number, so dividing a purely imaginary number divided by a constant will keep it a imaginary number. So a squared plus b squared all times I is purely imaginary. So z to the power 3 equals k to the power 6 plus k to the 6 I, where k is a real constant. So in an Argand diagram, so real part here and the imaginary part here, and the distance will be exactly the same. And since the real and imaginary are the same, this angle will be pi over 4. So k to the power 6 plus, I'm using Pythagoras. A squared plus b squared is equal to c squared. This is c squared. C squared, a squared, b squared. But in reality, this is k to the power 6, and this is also k to the power 6. So k to the power 6 squared plus k to the power 6 all squared is equal to c squared. So c is equal to square root of 2 k to the power 12. C is equal to square root of 2k to the power 6. And so this is the modulus, and the angle will be pi over 4. So we can rewrite this as z to the power 3 is equal to k square root of 2k to the power 6 is pi over 4. Then we can take, so we can multiply, so we can do this, so z to the power 3 all over 1 over 3. So that will be, which just cancels each other out to create z. So square root of 2k to the power 6 is pi 4 all over 1 to the power 3. So yeah, and so using De Moivre's theorem, it's 2.5 k6 is pi over 4 or to the power of 1 over 3. So from De Moivre's theorem, this is pi over 4 will be divided by 3. And for the others, the normal exponential rules will be applied. So pi over 12. Z is equal to, let me just make that clear, 2 to the power of 1 over 6 plus k squared, is pi over 12. Actually, no. But this is actually 2k pi, since yeah, we want to see because how do I explain this? Yeah, so essentially from every angle you want to see which is possible. So this is pi over 12 plus 2k pi all over 3. You just want to test out every possibility. So k equals, we want to test out each possibility in between 0 and in between 0 and 2 pi. We want to get, so anything over 2 pi in here is, so we want to get this in between 2 pi, so k equals 0. We'll create 1 to the power 6 k squared. This is pi over 12. K equals 1 to 1 over 6 k squared. 2/3 for us is 7 pi over 12. K equals 2. Alright, 4 over 3. So right. Oh wait, no. Wait. Oh no, this is 9 pi over 12, which is, this is 3 pi over 4. Then the other one, k equals 2, so 4 pi, k will be 4 pi over 3. Then 2 to the power of 1 over 6 k squared. This is 4 pi over 3, 16 pi over, which is 17 pi over 12, I believe. Yeah. So k equals 2. Yeah, so 17 pi over 12. So And z, so because the original question was z to the power of 3, there will only be 3 solutions. So if z is a complex number, z plus 16 equals 4 square root of z plus 1, find the value of absolute value of z. So the absolute value of z can be rewritten as x squared plus y squared, where y is the imaginary axis. So an absolute value of this, we can pair up the real parts, plus iy is 4 x, I forgot to mention z is equal to x plus iy. So x plus 1 plus iy, absolute value of that. So we take this, we square the real parts and imaginary parts, so 16 plus x plus 16 all squared plus y squared. And take the square root of that, since that's the equation for distance. X plus 1 all squared plus y squared. We want to square both sides, so x plus 16 all squared plus y squared is equal to, so remember we square, so we squared this side, and so we're also squaring 4, so 16 gets x plus 1 all squared, plus y squared, so x squared plus 16, oh no, not 16, 32x plus 256 plus y squared is equal to 16 brackets x squared plus 2x plus 1 plus y squared. So x squared plus 32x plus 256 plus y squared is equal to 16x squared plus 32x plus 16 plus 16y squared. So which is 15x squared, since we take minus x squared on both sides. We take the 32x, they just nicely crosses each other out. Minus, so 216 minus 256 is minus 240 plus 15y squared is equal to 0. We can divide all by 15. 240 divided by 15. X squared plus y squared. Take away 16 equals 0. So the original question was asking absolute value of z, and that is an absolute value of z is square root of x squared plus y squared. So x squared plus y squared is equal to 16, and take square root of both sides. So x squared plus y squared is equal to 4. And since absolute value of z always cancels out the negative, that we only consider 4. So absolute value of z is equal to 4. Question 2 done. Last part. So u equals 5 plus mi. Given the argument of u is equal to find the exact value of your number m. This means modulus of u equals 6, and So how modulus is defined is imaginary parts, real parts, and use Pythagoras here since this is a right angle triangle. So modulus of u is equal to 6. So this part is 6. The real part is 5, and here is m that we're trying to find. So Pythagoras triangle m squared plus 5 squared is equal to 6 squared. M squared is equal to 11. M is equal to plus minus 11. But if m is equal to negative 11, this means this will be this means this means it will go in the lower quarter, which contradicts the statement of argument u is between 0 and pi/2, which is the first quadrant. So m is only equal to positive square root of 11. So we want to multiply by the conjugate. So 18 for take away 2 square root of 3 times 4 plus square root of 4 plus 2 square root of 3 over 4 plus 2 square root of 3. 30. No, that's not 32. 72. 72 plus 36 square root of 3 over 16. Take away 2 squared times 3, which is 72 plus 36 square root of 3 all over 4 times 3 is 12, so which is equal to is that 18? I think, yeah, it's 18. 18 plus 9 square root of 3. Okay, so we got this. Page 8. So 2 more. So just 3 more questions. One solution. Okay, so with this a complex solution, there always has to be the conjugate, since square root of blah blah blah. So there always has to be a conjugate, because this will be square root. This will be something I. So in x equals negative b plus minus square root b squared minus 4ac all over 2a. The discriminant will be negative, and so it will create a I and a conjugate pair. So whenever a root is complex, that the conjugate must also appear. So the fact this just z1 is equal to 2 plus 5i, z2 is equal to 2 minus 5i. I will not recommend this. This is literally just pain. Wait, let me think. Yeah, so that means z minus 2 plus 5i and z minus 2 minus 5i and there is another solution. Let's just say actually we know that it's probably 4. Yeah, the coefficient is 4, so 4z let's just call it not A, T is equal to 0. So multiply this out. So z squared minus z2 minus 5I minus z2 plus 5I 5I minus and a plus 5I 2 minus 5I then for z take away t. I hate these expansions. Z squared take away 2z plus is that? No, that's a z. Plus 10zi take away 2z take away 10zi, so these two cancels out. Plus the conjugates cancel out, so 4 plus 25 is 4z take away t equals 0. Z squared minus 4z plus 29 4z minus t is equal to 0. We expand this out, 4z cubed minus tz squared plus minus 16z squared. That's a minus. Is a minus? Whatever. It's probably I probably should do a plus actually. I should change it. So 4z squared. So this should change to a plus here. That and so 4z take away 4tz. 29 times 4, that is 116, I believe. 116z plus 29t equals 0. So we pair up the 4z cubed, and then we can just factor out z squared from these. So t take away 16 z squared, and we can factor out the z from these. And, I'm just being here. So 116 minus 40 z plus 29 equals 0. And if we look back at the equation here, t minus 16 is equal to negative 19. Yeah, so actually, the coefficient on z squared is negative 19. So t minus 16 must be negative 19, so equals negative 19, so t equals negative 3. Let's check this out. Since 116 take away 4 times t, 116 take away 4 times negative 3 is equal to 128, which is exact same as here. So t, we can confirm that t indeed is negative 3. So yes, so to find the value a is 29t, so 29 times negative 3 is equal to negative 87. 29 times, yeah, that's negative 87. Negative 87, which is equal to a Then yeah, so we also know that 4z plus t is one of the is equal to 0. 4z take away 3 is equal to 0, so z equals negative 3 over 4, and that is the other solution. So the two other solutions are 2 minus 5i and negative 3 over 4, and a is equal to negative 87. So to get rid of the square roots, we want to square them. So 6 square root of 2x take away 5 squared is equal to 6 square root of 2x plus m squares. That's 36 times 2x take away, and then a simple trick is you just multiply negative 5, and so a simple trick for squaring is ax plus b. So simple trick you can do is 2ab times x is the middle number. So 6 square root of 2x times negative 5 is negative 30, and negative 30 times 2 is negative 60. So negative 60 and square root of 2x plus 25 is equal to 36 2x plus m. So 72x take away 60 square root of 2x plus 25 is equal to 72x plus 36m. These two crosses out, so and let's just rewrite this. Let's just take this to here and take this to here, since we want x to be the subject. So 25 minus 36m, it's in the way, minus 36m is equal to 60 square root of 2x. And to get rid of square root, we want to square everything. Can I do it? I might just do this actually. I might just divide both by 60 is equal to square root of 2x. Then we square this. 25 minus 36m all squared all over 3600 is equal to 2x, and we're dividing by 2, so let's divide this by 2, so x is equal to 25 minus 36m all squared all over 7200. So for this, just keep on squaring and just get the answer, I guess. Last question. So z is equal to x plus iy. The absolute value of z is equal to x squared plus y squared, square root of that. So x squared plus y squared, square root of that. Actually, the square root just cancels out with squared here, and once again the square root. Oh no, never mind. This is an absolute value. X plus iy all squared equal to I brackets. Yeah, so here it cancels out, so x squared plus y squared take away 4, x squared plus 2 ixy plus, actually let's take away since that's I squared. Take away y squared is equal to x squared I. I like that I is a constant actually. Plus y squared, take away 4i. So, okay, so we can rearrange this to x squared, take away y squared, x squared plus y squared plus 2i xy is equal to I x squared. Actually no. I shouldn't have expanded this out. So I'll just factorize it again. X squared plus y squared minus 4. So the big idea in complex numbers is equating the real parts and imaginary parts together. So if we equate the real parts, the imaginary parts, it gets this, and the x squared take away y squared must equal to the real parts, but there is no real parts here. Therefore, but there actually is a plus 0, so the real parts must be 0. So x squared minus y squared is equal to 0 when equating the real parts with real and imaginary parts with imaginary. So x squared is equal to y squared, so therefore x equals plus minus y. Then it wasn't. Solve the equation, so I must get exact numbers. So let me just write that out. Let me just say, explicitly say x equals negative y and x equals y. So, and we equated the imaginary parts with imaginary, so we can just cancel the imaginaries out. So 2xy is equal to x squared plus y squared, take away 4. Plug in that. Let's just plug in negative y for this. So 2 brackets negative y is equal to negative y all squared plus y squared, take away 4. Negative 2y squared is equal to 2y squared, take away 4. That is 4 equals 4y squared. Y squared equals 1, so y equals plus minus 1. Then if we wait, is that okay? Let's use, and then if so, let's use x equals y. This means 2x brackets x, since we're putting x into here, is equal to x squared plus x all squared, take away 4. 2x squared is equal to 2x squared minus 4, but this cancels out, and this actually creates a impossible equation. So this, the only possible way is y equals plus minus 1. So so which is impossible. So we know that x equals negative y, and so when y equals plus minus 1, so when y equals 1, then x equals negative 1, and y equals negative 1, then x equals 1. Yeah, so this is a bit unclear, but from what I interpret it, so the equation, I'm guessing that they're asking for in terms of z. That is what I'm guessing. So and remember z is equal to x plus iy, so this equation creates negative 1. Right, let me just, z is equal to negative 1 plus I, and this one creates z equals 1, take away I. Yes, so those are the two solutions to the equation. Thank you for watching this video, and yes, goodbye.